this is Arindam Biswas once again before you to present one more series of video. This time I have chosen the video for application of derivative, that is rate measure, as we have already seen in the introduction part video. You know that you can surely get a question of 4 marks from the application of derivative. Already I have discussed it. One of them was maxima, minima, then Rose theorem, Lagrange's theorem. We have also increasing and decreasing functions. One more topic is that is rate measure, which is a very important topic. We may expect a question from rate measure also. So we need to focus on the chapter a bit. Although it is a very easy topic, we need not worry about it. Even if you have not studied, just focus on it. Just a concept I shall give you. I think that even in the last minute you shall be able to cope up if any problem comes from rate measure. Before that, I would like to tell you that whatever you have studied, I suppose you are revising well, and you are going through the problems that you have already practiced throughout the year, so that you do very well in your examinations. So once again, the reminder I would like to give you about the subscription of the channel. Those who are going to give the board exams, please tell your friends of class 11 or class 10 to subscribe my channel if you have been benefited, and if you have any comments to improve the channel, surely I request you to give in the comment box. Even my WhatsApp number or the mobile number, you can ask for me in the comment box. I shall provide you whoever needs. Anyway, so let us start with the concept of rate measure. I shall do a few selected problems which will be helpful for you to do the remaining problems. What is actually rate measure? Rate, we know that it changes. We know derivative means the change of the dependent variable with respect to the independent variable. We usually write dy by dx. dy by dx, where y is a function of x, where y is a dependent variable and x is an independent variable. So when we write dy by dx, we actually mean to say that change in y with respect to x. If we write dv by dt, where v is the velocity and t is the time, that means change in velocity with respect to time. Or if I write dx by dt, that means change in x with respect to time. Dx by dt means change in x with respect to the change in time. So usually we have in rate measure the questions, practical based questions. So without wasting much of our time, let us see a few examples which I think will clarify most of your doubts or queries regarding rate measure. So let us see the problems.
Find the rate of change of area of a circle with respect to its radius when the radius is 6 centimeter. So we have to find out the rate of change of area with respect to the change in radius. So we know area of a circle is given by the formula pi r square. So let A equal to pi r square. A is a function of r. Now change of area means dA by dr. That will be, you have to find out the derivative of pi r square. Pi is a constant, so derivative of r square with respect to r is 2r. Now we have to find out actually the derivative at r is equal to 6 centimeters. So we just place the value of r is equal to 6 in this derivative. So we get 12 pi centimeter square per centimeter. So this is the rate of change of area with respect to the radius. If the sides of a square are decreasing at the rate of 1.5 centimeter per second, at what rate is the perimeter decreasing? That means we have to find out the rate of decrease of the perimeter when the sides are decreasing at the rate of 1.5 centimeter per second. Let us see the solution. What is given in the question is the rate of change of the side. So let the side be x, then dx by dt is given equal to 1.5 centimeter per second. We have to find out the rate of change of perimeter. So we know perimeter of a square is given by 4 into side 4x. So now rate of change of perimeter means dp by dx, that is 4 into dx by dt. Now what is dx by dt? That is 1.5. So 1.5 means 6 centimeter
The volume
centimeter
of
per
a cube is
second.
increasing at the
So
rate of 9
rate of
cubic
change of
centimeters
perimeter
per second.
with respect
How
to the
fast is the surface
change in
area
the
increasing
side of the
when the
square will
length
be
of
6
the
centimeter
edge is
per second.
10 centimeters?
The volume of the cube is increasing at the rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of the edge is 10 centimeter? So in this question it is given that dV by dt is 9 centimeter cube per second. That is change in volume with respect to time. We know volume is given by side cube. So if I find the derivative dV by dt, that is equal to 3x square dx by dt. Now it is already given dV by dt is 9. So 9 is equal to 3x square dx by dt, or dx by dt is equal to 3 by x square. Now what we have to find in this question is change in surface area. So let A equal to 6x square, because surface area of a cube is 6x square, or 6 into side square. So dA by dt will be equal to 12x dx by dt, and dx by dt is given, we have already calculated, that is 3 by x square. So 12x into 3 by x square, so that is 36 by x. Now 36 by x, so change, we have to find out the change when the edge is 10 centimeter. So when it is 10 centimeter, dA by dt will be equal to 36 by 10, that is 3.6 centimeter per second. Sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is always 1/6 of the radius of the base. How fast is the height of the sand cone, or height of the cone, increasing when the height is 4 centimeter? So according to the question, it is given that a conical heap is produced when sand is poured from the top. Relation between the height and the radius is, if height is x, then the radius will be 6x. That means the radius is 6 times more than the height. So we know the volume of the cone is given by the formula 1/3 pi r square h. So 1/3 pi, and r is 6x, so 36x square, and height is x. So on simplifying we get 12 pi x cube. Now change in volume means dv by dt we have to find, that is 12 pi, that is a constant. Derivative of x cube is 3x square dx by dt. But already in the question it is given the change in volume with respect to time is 12 centimeter cube per second. So this is 12 is equal to 12 pi into 3x square dx by dt. So 12 gets cancelled. So dx by dt is 1 by 3 pi x square. Now when the height is 4, so dx by dt will be 1 by 3 pi. Height is 4, that means 16, or 1 by 48 pi centimeter per second. So this is the change in the height when the height is 4 centimeter and when the change in volume is given 12 centimeter cube per second.
Well, the examples which I have explained in this video, I think you have understood. The concept is quite clear to you. Please go through the examples and try to do the sums of the exercise. I suppose you will be able to do it. In case you have any doubt, don't hesitate to write in the comment box. Immediately I shall reply, and I think there will be no problem. Best of luck once again for your exams. Hope you all will do well, and see you again with smiling faces after the exams. Thank you. Bye bye. God bless.